All right, let's get right into it. You know that simple upload button you see on practically every website? Well, it might just be one of the biggest security holes on the internet. Today, we're going to peel back the layers and figure out how to lock it down for good.
I mean, it seems so harmless, right? You click it, you upload a profile pic, what's the big deal? But what if that file isn't really a picture? What if hiding inside is a script designed to hijack the entire system? That's the question we're tackling today, because the stakes, they're incredibly high.
So to wrap our heads around this, we're going to use an approach called the layered defense. Think of it like a security onion. We'll start on the outside with the most basic checks and work our way in to the core protections. We'll look at the dangers, walk through 3 key layers of defense, and then meet the final guardian that watches over everything.
First up, let's talk about the problem itself. A file upload feature is literally an open door into your server. And if you don't have the right security in place, you're essentially rolling out the red carpet for attackers to come inside and drop off whatever nasty surprises they want.
And believe me, those surprises can be absolutely devastating. We're talking remote code execution, where an attacker gets a web shell and takes complete control of your server. They could steal sensitive user data, or just crash your whole system with a denial of service attack by uploading a giant file that eats up all your disk space.
So where do we even begin to defend against this? Well, let's move to our first and most basic layer, the gatekeeper. This is that first line of defense, and as you're about to see, it's a pretty flimsy one.
The simplest thing to do is just look at the file's name. The server sees an extension like .jpg and says, "Yep, you look safe, come on in." Then it sees .php and goes, "Whoa, no way, you're definitely not allowed here." This is called whitelisting, and it seems like a decent idea at first. But what happens if the attacker just lies? They take their malicious exploit.php file and just change the name. Suddenly, it's called exploit.jpg. The gatekeeper sees that JPG extension, waves it right on through, and boom, a dangerous script is now sitting on your server, just waiting for its moment.
And this really gets to the heart of why relying on names is such a bad idea. Portswigger's Web Security Academy says it perfectly. Trying to block every bad extension, which is called blacklisting, is basically impossible. There are just too many weird, obscure file types an attacker could use. It's a game you're always going to lose.
Okay, so the gatekeeper obviously isn't cutting it. We have to go deeper. And that brings us to layer 2, the inspector. This is where we stop trusting what the file says it is, and we start looking at what's actually inside it.
Now, the main tool for our inspector is something called magic numbers. And no, it has nothing to do with wizards, it's way cooler. See, most file types have a unique signature, a specific sequence of bytes right at the very beginning of the file that acts like a digital fingerprint, revealing its true identity.
Take a PNG image, for example. A real PNG file will always start with these exact bytes. A PHP script, even if an attacker names it cutekitten.png, will not. So by checking these magic numbers, the server can be way more confident that the file is what it claims to be. It's a much, much stronger defense.
But, of course, the cat-and-mouse game continues. Really clever attackers can create something called a polyglot file. It's a maliciously crafted file that is somehow a valid image and a valid script at the exact same time. It can pass the magic number check for an image, but still hide malicious code inside. So even our inspector can be tricked.
And that brings us to our most critical, most robust layer of defense, the fortress. The whole idea here is to assume the worst. Assume a malicious file somehow got past the first 2 layers. The goal of the fortress is to neutralize that threat after it's been uploaded. This diagram shows you exactly how it works. An uploaded file doesn't just get dumped into a folder. Now, it has to go on a journey. First, it hits a presentation tier for basic checks. Then it moves to an application tier for some really deep validation and cleaning. Only after it's been through all that does it finally get passed to a secure storage location.
And this table here, from some fantastic research, really shows how these defenses build on top of each other. You start at scenario B, our simple extension check. Then you add more and more layers, server-side validation, file name sanitization. By the time you get all the way to scenario F, you've got this incredibly robust system that resizes images, generates unique file names, and creates multiple, painful hurdles for any attacker.
One of the most important steps here is sanitization. An attacker might name their file something crazy like //etc/password to try and break out of the uploads folder and read system files. Well, this code stops that cold. It actively hunts for and removes those dangerous characters, completely neutralizing the threat. And this right here is my favorite trick: image resizing. It's not just about making the picture smaller. When your server resizes an image, it's actually creating a brand new, clean image file from the pixel data of the original. This process is like laundering the file. It strips out all the malicious junk and hidden code an attacker might have stuffed in there. Then you just delete the original, potentially dangerous file. Brilliant.
So let's run through the Fortress checklist. First, never ever use the file name the user gives you. Generate a new random one. Sanitize everything. Reprocess images to clean them. And this one is huge. Store the files somewhere totally separate from your web server, in a non-executable location like an S3 bucket. Finally, in your database, you only store a pointer to that file, not the file itself.
Now, even after all of those layers, all that work, there's still one last thing we can do. Think of it as the final guardian, the watchtower that's always on the lookout for trouble.
And that guardian is a good old-fashioned antivirus scanner. This is your ultimate safety net. It's not just about protecting your server, it's about protecting your users who might download these files later. It's fantastic at catching those tricky polyglot files and other known malware, plus, in many cases, it's actually a requirement for compliance. But if you're going to scan, you have to think about the user experience. You could do a synchronous scan, where the user uploads and then just has to sit there waiting for the scan to finish. It feels slow. A much better way is to do it asynchronously. The upload feels instant to the user, and the scan just happens quietly in the background. If a problem's found, you can just let them know later.
Okay, let's wrap this all up. If there's one thing to take away from this, it's that there is no single silver bullet. You absolutely need a defense in-depth strategy. Always use a whitelist of what's allowed. Check the file's content with magic numbers, not just its name. Sanitize, rename, and reprocess everything. Store it securely. And for goodness sakes, scan every file as your final backstop. So I'll leave you with this final thought. That upload button, it's a doorway into the heart of your application. The real question you have to ask yourself is this: have you checked every single lock on that door? Because an attacker only needs to find one you forgot.